Okay, question 3. A spherical mirror produces a real image that is the same size as the object. So from this question, we can already see that this is a concave mirror. Okay, so if the object is 22 centimeters, so positive, in front of the mirror, we have to calculate the image distance. So this one, we will be using the equation of magnification, because from the question, it has already give us the image size lah, which is same size. So if you were to calculate it, hi over h naught, you will be getting 1 because they are at the same size. So m is equal to negative v over u. So our v will then equal to so the magnification will be negative because, let's look at the table. Okay, so dimension, so produces a real image that is the same size as the object. So for this case, if you look at the table, where is our table? This one. So if you look at this, it will tell you that the characteristics lies on which one? It is on this. Not that one. Same size, this one. Okay, so that situation is for this one here. Okay, so since the image will be inverted, the magnification value would be -1. Okay, so from here you will then get the image distance to be equal to 22 centimeter. Okay, because it needs to be in front of the mirror. Okay, it should be a real image, it should be positive. Okay, so that's why the magnification should have -1, because it would produce an inverted image lah. Okay, which is the same with what we see in the characteristics for this situation. Okay, and then we have to calculate the focal length of the mirror, so that is just 1 over u plus 1 over v, so that will give you 11 centimeters the focal length lah. Okay, so now the situation is for, because we need to draw the ray diagram, I'm not gonna draw it again because I think it takes a lot of time, but basically the ray diagram would be this one here. Okay, so how do we know that the image distance, the object distance is equal to r? Is we know that r is equal to twice the focal length. So this would gives you 22 centimeter. So this situation is applied for object distance equal to the radius of curvature. So this is the ray diagram. Okay, this one. So what you need to do is remember that for concave mirror, the principal axis, all the center of curvature, all of this is gonna be in front of the mirror. Okay, so firstly you are gonna draw the object. So it would be at the radius of the sphere, which is gonna be at the center of curvature lah, because we state that the object is equal to the radius of curvature, which is this point. Okay, boleh? So this is gonna be here. So the first ray, you will be drawing it from the top of the object parallel to this principal axis, and it will be reflected back going through the focal point. Okay, so it will pass through the focal point. And then the second ray, you can draw the going from the top of the object, passing through this focal point, and then being reflected back parallel to the principal axis. Okay, another line that you can draw is going from the top of the object to the center of curvature. Okay, so it will, you can't actually draw that. You just focus with 2 saja lah. Okay, kalau macam tu 2 lah. Okay, but then if you draw it like this, you can actually get the point here, which is telling us the image is just inverted and has the same size with the object lah. Okay, boleh lah to, and that is on question number 3